All right, welcome back. We are continuing on lesson 5.3, and your focus for today is going to be able to graph the solution set for linear inequalities in two variables. So, just so that you know, you've been graphing linear inequalities since I know for sure eighth grade. Some of you, just depends on how your teacher taught it, was seventh grade and even earlier. And if you've been thinking about inequalities, you've probably been thinking about them since you weren't tall enough to ride that ride, right? That's where inequalities show up. So you should be able to answer these questions. How can I find the complete set of points that satisfy a given constraint? And how do I represent the complete solution set? So if you can think about complete solution set is very different than the solution. So take these words out, take out the word complete, take out the word set, right? If you take these two words out, and we're just talking about equations, it's just one answer, right? X is equal to 10, or perhaps 3 comma 4, right? But when I say a set, if you know what the word set means, we're not dealing with one thing or one set of things. I'm not one point. We're dealing with a whole lot. Okay. So we're continuing with Carlos and Clarita. They're still trying to build that business. It says, as Carlos is considering the amount of money available for purchasing cat pens and dog runs, he realizes that his father's suggestion of boarding the same number of each, perhaps 12 cats and 12 dogs, may not be reasonable. And then we said, why? The startup cost for Carlos and Carita is 1,280. I'm going to pause right there and we're going to answer number one. So it says, find at least 5 or more combinations and dogs that would be too big based on this startup cost. Plot each of the combinations as points on a coordinate grid. Okay. So I think we did do this question. If you think about it, you can choose like some crazy number. Like dad says 12 and 12, and 12 and 12 don't work specifically because, right? Specifically because if I punch this into my calculator, I think I need to go on this side so I can actually see everything. Sorry. Um, so this part right here, it says 1,280 and it costs $32 for each cat pen and $80 for a dog run. So then we would plug this in and go like this, right? We'd say 32 times 12 plus 80 times 12 equals to 1,384 or 1,344. Why is this wrong?
May I say?
Mm-hmm.
It's more than our budget.
Yeah, our budget's $1,280. Carlos and Clarita are holding to the fact that they're not going to go into debt for this business, so it's way too much money. And then they asked you to, come up with more points, right? That would not work. And I think we came up with a couple of points, so I'm just going to move forward on this part. And then it says, find at least 5 combinations that would be not too big based on the startup constraints, not too big. So here we're basically using the Papa Bear, Mama Bear, Baby Bear strategy, right? So too big, too small, just right. So you can think of combinations like this. I'm going to change these numbers. Can I copy from here? Nope, I can't. So 32 times 1 plus 80 times 1. That would be under budget, wouldn't it? Right? What's the problem with having one cat and one dog? One cat run, one dog run.
May I go?
Yeah.
It's much too under budget, much too under space.
Yeah. So, for example, I'm not going to make enough money, or I'm not going to have enough houses or cat dogs and dog runs, whatever they're called, in order to house all the customers that might come, right? So now we want to find combinations that are just right, that are just right. So then if you want to know how would I use this calculator to find all the combinations that are just right? What would I do? Any ideas? What would I do?
Maybe you can make an inequality of something like the budget, like less than or equal to $1,218, and then I forgot the amount of space we have, but less than or equal to the amount of space.
So right now we're just talking about the money budget. We're not even going off of the space budget or space available. That makes sense. Can you guys write me a something that matches that? Okay, so we are trying to find. Okay, now remember, if we're gonna do this, this is like Papa Bear, Mama Bear, and Baby Bear, right? This is too. The chair is too big. The chair is too. No, the chair is too hard.
It's the porridge. It's the porridge. If the porridge is too cold, but it's like.
Wait. What's too big, too small, just right? Isn't that their bed? Or is the chair too hard?
The entire story is first the porridge is too cold,
too hot,
too cold,
just right.
The bed was too hot, too cold, just right.
No, the bed cannot be too hot. The bed is okay. We're really
too big, too this, too that.
Okay, I'm gonna go with bed.
It was too big and too hard, or too soft.
Yeah, I think
it was just right.
I think the chair is too hard, and I think this bed was too whatever. We're just gonna go with bed. Okay, so Papa Bear too big, Mama Bear not big enough, Baby Bear is just right. Right?
I gave you mine.
Yes. So it's not for this one. It's not an inequality. So if we're going for just right, it's an equation. If we're going for an equation, we're going for an equation. So just change that to an equation. So here's the equation right here that you guys see. So I'm going to write the equation as 32x. I'm going to pretend x is cats plus 80y equals to 1,280. Johnson, I don't see anything. You are right. Here it is. So where would my just rights be? Where would my just rights be? In this picture, where would my just rights be? No, not on the intercept. Well, I mean, technically on the intercept, but that's not the only place. Anybody know where my just rights are? Yeah, my just rights, very good, are anywhere on this line. Anywhere on this line, except for some of them won't make sense, right? Oh, I can't even do that. So if I take my finger and I know, right? That's what I meant. So if I take my my point and travel all along here, I'm getting all of these as solutions to that equation. But bringing it back to our context, I agree with what one of your classmates said. That answer doesn't make sense. 34.1 comma 2.36 is gross. What is 34.3 of a cat? I know, pet butchers. That is gross. I agree. So all of these are going to be just right. For example, wait, let's try to get this. Let's try to get like 39 is not going to make sense. Let's see. 37 doesn't make sense. Let's try to get, can anybody find some pretty good points? Look here and try to figure out what numbers those would be. Give me a couple good points along there. I see 1, 2, 3, 4, 5. I see exactly 5. Do you guys see them? Where do you see it? Give me just one. One good, just right. Someone says 0, 10. So no cats. Oh, just kidding. Sorry. I'm sorry. Okay, sorry. Someone said, wait, just kidding. Someone said 30, 2. Ooh, yeah, that's a good one. Everybody look at 30, 2. 30, 2. Let me try to get that on there. This is hard because my finger does it. Oh, wait, not 30, 2. I understand what you said too, though. 30, 4. That's what you meant. I got you. Everybody okay with 30, 4? Everyone write down 30, 4 as your baby bear. Just right. Just right. Someone else said 0, 16. Let's see. 0, 16. Yep. I got to write these down. You said, what did you guys say? 30, 4, 0, 16. I need a couple more. Someone says 514. I don't know if 514 is right. 514.
Can you search up for specific points in the graph? Like
oh, 514 is good. Wait, what?
Are we able to like search up for specific points in the graph?
Oh, that's a great idea. Yes, ma'am. Let's do that. Someone said, Miss Johnson, just plug the points in and see if it works. Okay. So yes, yeah. So yes, 514 is good. Even though it didn't look good, it is good. So can you guys find me 2 more good points? Find me 2 more good points on here and then write them down. Okay. Where is Papa Bear? According to this picture, where would Papa Bear's too big? We're spending too much money.
Oh, I'm sorry. May I?
Yeah, go ahead.
Anything above the line?
Wait, stop. Don't say anything else. Above the line. Above the line. Can everybody pick a point above the line? Just pick one. Just pick one. Like on your screen, point at it, like touch your screen. If we were in class, in physical class, I'd all make you draw it. There's something to be said about like tactical learning. So yeah. So did you pick one? So someone says 30-20, Miss Johnson. 30-20 is a Papa Bear point. Is that true? Is that spending too much money? And then I'd be like, I don't know. Let's check. Let's put it over here. So let's put 30 cats, 20 dogs. Whoa, that's too much money. Like, they can't even take it. Is everybody okay with that? Now pick a point that's too small. I'm thinking I'm remembering this wrong. Is Mama Bear perfect? I'm going to let go of Goldilocks.
Baby Bear is perfect.
Okay, sorry. Thank you, Johnny.
If Baby Bear relates to Goldilocks somehow because they're both young, I presume.
Because they're tinier?
Yeah.
And how is a bed too soft? Is that
They're about the same size.
No, like the mattress is uncomfy because it's like squeaky or squishy, you know.
Very good. Okay, someone's bringing me back to reality. Miss Johnson, 5,5. Yeah, that's way too little money. Like, we're not spending enough. Is it okay for them to get less to start off? Yeah, sure, why not? But they asked for perfect. So how would you describe Mama Bear? This person says above the line for Papa Bear. How would you describe Mama Bear? Yeah, below the line, under the line. In math, we would say less than. Hint, hint. Nudge, nudge. Wink, wink. Do you guys all see where I'm going with this? Okay, very good. All right, moving on. Okay, really good learning there. We were supposed to graph it here. I didn't. Okay. What do you notice about these 3 different collection of points? You guys all know this. What did you notice about these 3 collection of points? Between on the line, above the line, and below the line. Right? Yeah. Someone's even relating this to equal to, less than, greater than. Very good. That's what you're supposed to. It says write an equation for the line that passes through the points representing the combination of cats that cost exactly that. Do you guys know what equation this is? We just talked about this, yes? What equation would this one be for number 3? What equation would that be? Yeah, the equation that we just wrote right here, right? So go ahead and write that equation down quickly before you forget. Write that equation down.
One thing I don't like about decimals is that you can't have the same color like throughout your slides. You have to keep adjusting it.
What do you mean? Like this? You want to change this color?
No. For the slides, like when I move to a different slide, I have to choose my colors again.
Oh, I see. I thought you were talking about this Desmos, but you're talking about your slides. Yes, ma'am. Very good. So you should have written it. It says exactly, right? So we're talking about Baby Bear here. So you should have written the point 30. Oops. 32 x plus 80y equals 1,280. So the question that I have for you is this. The question that I have for you is this. Y 32, y x, y plus, y 80, y equals y 1,280. If you're trying to boss this up, you're not just like, oh yeah, let me write that equation down. You're like, I know exactly why 32 is 32. Exactly. Because 32 is the cost for a cat pen, right? Why are you adding these things? Because essentially, this is money that I spent on the cat pens. This is money that I spent on the dog runs. And this is the total amount of money that Carlos and Clarita have, right? So if you're trying to boss this up, you're not just writing an equation down. You understand where everything is coming from and why you are putting it there. Okay. So, truth be told, when I was like in, I don't know, fourth, fifth, sixth grade, maybe seventh grade too, whenever they give me a word problem like this, I would figure out, do I add it? Do I subtract it? Do I multiply it? Do I divide it? Yeah. Yeah. And so now that you're in high school, you're stepping it a step up because now not only are you doing it, but you understand why you're doing it. Okay. If you're stuck in the land of, I don't know what I'm doing, don't try to do all the problems. Try to do one problem really well. Don't try to do all the problems. Okay. Moving on. Carlos and Clarita don't have to spend all of their money on cat pens and dog runs unless it'll help them maximize their profit. Shade all the points on your coordinate grid that satisfy all the startup costs and constraints. So how do I shade this, Miss Johnson? How do I shade this? Well, where do I want this to be? Go ahead.
To shade it, I'm sorry, I keep raising my hand, but
Mhm.
to shade it, you make it an inequality because it shades it out.
Yeah. So which one would I put here?
Less than or equal to?
Like that? Or
Yeah.
did you want this one?
No, that's the Papa Bear side.
Yeah, we don't want Papa Bear. Papa Bear, we don't have enough money for. So we want to go with Mama Bear. Even though Mama Bear has us spending less money, I'm okay with that. Because when your parents send you to the store with money, they don't technically expect you to spend every single penny. I mean, some of you will keep the money, but hey, they don't want you to spend more than that. But I don't necessarily agree with this, right? There's something wrong about this picture. I'm going to plant that seed and I'm going to move on. You all should be thinking, what's wrong with it? Okay, I'm going to move on. Okay, so we shaded that. Write a mathematical rule to represent the point shaded in problem 4. That is, write an inequality whose solution set is the collection of all the points that satisfy those startup costs. Here's your inequality, but I'm still going to say something looks wrong about this. Okay, something looks wrong. Something is wrong. I'm going to tell you right now, something is wrong. Yeah, actually, don't say anything though. Don't let everybody else figure that one out. So something is wrong with this, Miss Johnson? Yes. Okay. So I've got one person who figured it out. I'm going to keep going. In addition to the startup costs, Carlos needs to consider how much space he has available based on the following space. So cat pens will take 6 feet of space, while dog runs will take 24. Carlos and Clarita have 360 feet squared available storage shed for pens and runs, while leaving enough room to run around and to move around the cages. I want you to write the inequality for space. Okay, here's all the information that you need. Here, let's highlight together. They told us 6 feet. They told us 24 feet. They told us 360 feet. I want an inequality because that's what it says. Give me an inequality. So it's going to be blah, 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 greater than or equal to, less than or equal to, greater than, less than, one of those things, and write that down. Okay, I'm going to pause really quick. Okay, so some of you were sending me it in the chat, which is awesome. Now you put 2 of them. Now, because it says inequalities, I do want the one that has like one of these symbols in it, right? The less than, greater than. So how did you build this equation? Yeah, very good. Someone said, I like, huh?
While we do space, do we have to worry about the constraint for cost? Or should we just do for space?
What does that mean? Tell me more.
I'm sorry, but let's say I choose a never ending number. It hits exactly for our space limit. But if we mark it on the range of the cost and the spending money we have, it doesn't work.
So just ignore, like pretend that they're independent of each other, and let's see
Okay.
what's happened.
Okay. Okay.
So if you don't understand what Janaki just asked, like all she's asking is, do you only want me to give you the inequality of the ones that fit within the cost constraint, like the cost um, restriction? And I said, no, just ignore that. Just totally go for this. Someone put 6C plus 24D is less than or equal to. I like the C and the D. That's why I wrote it there. In Desmos, I'm going to use 6X plus 24Y. Miss Johnson, where did the 6 come from? You should know that. Look in the things that I highlighted.
I'm
Go
sorry
ahead.
if that was I'm sorry if that was rhetorical, but six came from the space that the cat pens have.
Perfect. And then why did you add them together? Why did you make it less than or equal to? Less than or equal to for the same reason that we did less than or equal to there. Okay, so here is our inequality. Now I graphed them on the same one just so that you could see. Okay, so if you were Carlos and Clarita's consultant and you were telling them, this is one of the graphs that I would hand them and say, okay, this is one of the things that you need to look at. Everybody good on that? This is one of the things that you should look at. And everyone's like, okay, yeah. And then so this information here should help you make a decision, right? Okay. So this is going to be continued on 6.4. So we're going to keep this up for just a little bit longer. I just kind of want to show you your takeaways just so that we're all on the same page. I don't know if you guys remember this, but standard form of an equation, this is one of the questions for Ready, Set, Go. Looks like this. It's AX plus BY equals to C. Whenever we use this word standard, it means like the one that you're going to see the most. Do you see our equations on Desmos? Those are both standard equations. Standard meaning AX plus BY equals to C. To me, standard is the least helpful when graphing, but it's the most helpful when you're writing a context equation, right? Okay, slope intercept form, you all know, you love and know slope intercept form. That's our good friend y equals mx plus b, right? Y equals mx plus b. Oh, thank you, Nayeli. Very good. Okay, and then point slope form looks like this. Now, I'm going to tell you there's many forms of slope intercept, so point slope form. I'm going to show you both of them so that you're used to seeing both of them. Miss Johnson sees it like this. Okay. Some of your books, including this curriculum, shows it like this. So all of these are appropriately named. Slope intercept form is called slope intercept form because it gives you the slope and the intercept. Remember we talked about was this when we talked about quesadillas and cheeseburgers? Do you guys remember this? And you said that slope was cheese. Do you guys all remember this? Kind of? No? Yes. Okay, I got some yeses. So if they give you slope and intercept, I'm going to use slope intercept form. If they give me the point and the slope, I'm going to give them the point slope form. Does that make sense? Yeah, slope is cheese. Exactly. Okay. So the next part says the solution set of a linear inequality is a half plane. You've never heard this term before. This word plane does not mean plane sky, I'm going to go fly to New York kind of airplane. Plane is a 2D object, sometimes looks like this when I draw it. It's like a piece of paper that goes off forever in every single direction. Is everybody okay with that? Like, can everybody think about the biggest screen that they've ever seen? So, if it was a plane, it would literally go on forever in every direction, left, right, up, down, forever. There'd be no border. Okay, so that's what a half plane is. The solution set to an inequality constraint for a context like pet sitters. So what they're talking about here is it's a smaller set. So did anybody want to talk about what they see that is wrong here? What is wrong with this here? We actually started with this. If I unclick this red, I said this looks wrong. Did anybody pick up on this? I know you did, but did anybody else pick up on this? It has to do with what one of your classmates said and like 2.5 dogs. It's in that weird realm. Yes, very good. Okay, so I got 2 people on it. Anybody else? I'm just gonna wait for a couple more seconds. Yes, okay, I got 3 people. So go ahead and explain it, Missy. Good.
Hi. So my explanation is it should be a discrete function because the way that we look at these animals is we don't actually, discrete functions are more relative to the context. So if you look at the context of animals, there cannot be or should not be more so a half of a dog or 3/4 of a cat. Right, so that context tells us the answer that we should be looking for.
Very good.
While on the inequality plane, it shows us that we can have 3.746 or something like that. It doesn't mean we should have 3.746 relating to the concept.
Perfect. So if you don't remember what discrete means, remember it was all the dots not connected. So in this context here, all of I can't point to it so you would see. Here, let me plug in a point. So I would never have the point -4. Oh, that is that going to show up? Yeah, sure. -4, comma 2. That is a solution to this inequality. Does everybody see that? That's even a solution to this set of inequalities. That system, everyone's like, yeah. But it is not a solution to Carlos and Clarita's problem down here, up here. Does everybody get that? They can't have -4 dogs. Like, I don't know what a -4 dog or cat. That's a -4 cat. What does -4 cat mean? Do I owe you a cat? Like, ew. Is that like a dead cat that I've brought? No, I'm not. I'm just gonna be done. So in here, in the next couple lessons, you're gonna understand that we're gonna add more constraints to this, so we get even better at this. Okay. So let me pause this.